Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So today we'll be looking at chemistry and we'll be seeing calculation questions in chemistry. So the calculations you'll be seeing in your NECO WAEC or JAMB examinations in chemistry, you agree with me that chemistry has a lot of calculations. We have videos that have touched all areas of the theory or the explanations or about the concepts, but then we'll dedicate this video to seeing how we apply them in calculation. So sit tight and enjoy the video. Comment on our comment section if you have any reservations or questions. We'll be posting some questions in the comment section so you can react to those questions. Like the video if you enjoy what we are doing, and subscribe if you're able to subscribe. So let's dive in. I have a question on the board. It says we should calculate the number of moles in 18 grams of water. Okay, first of all, this is the chemical formula for water. Solution, we're going to find number of moles, and the formula, number of moles is given as mass in gram over relative molar mass. Mass in gram over relative molar mass. This is the formula. So we're going to calculate number of moles. And we're given the mass in gram as 18. So this expression is 18, but relative molar mass is not given. So for water, this is the chemical formula for water. We need to find the relative molar mass. So it is given by adding the individual molar masses of the element that forms the compound. So we start from hydrogen. The hydrogen has two molecules here. So, and this is one molar mass of hydrogen is 1. It's always going to be given. For all the elements that forms the compound, the molar mass will be given. So I will say molar mass of hydrogen is 1 times 2 molecules presented here, then plus oxygen has 1 molecule times 16. So 16 times 1. You get this point. So this one here, this first one here represents the molar mass, and these two represent the number of molecules present. So this is for hydrogen, it is 1 times 2, then plus oxygen, I have 16 molar mass times 1 molecule present. If I have 2 molecules present here, then I'll put 2 here. So I'm going to quickly do this maths. 1 times 2 is 2 plus 16 times 1 is 16. So the molar mass, relative molar mass of water is 18. So I can put it in this formula. Number of moles will now be equals to the mass in gram is given as 18 gram over relative molar mass, which is 18 gram per mole. That's the 18 gram per mole. Okay, so by the time we do the maths, this will cancel this. So it is having it as 1. The molar mass is 1 mole. Number of mole is 1 mole. So in this particular question, I have 1 mole of water. Okay, so we have number 2 on the board. It says that how many grams of sodium chloride, NaCl, we produce when 2.3 grams of sodium reacts with excess chlorine gas. Okay, so this is the molar masses of the element. So the first thing we do is to write out the equation of this reaction. Sodium reacts with chlorine to give us sodium chloride, right? Okay, so to balance it out, we all know that chlorine has 2 molecules here. Then I'll put 2 here so that I can have 2 outside. So this is the formula. So the mole ratio coefficient is 2 molecules of this, 2 moles of this react with 1 to give us 2. So 2 to the mole ratio 2 to 1 to 2. Where am I getting these things from? I'm getting it from here. This is 2 here. You understand? If this is a balanced chemical equation. So if you are doing a stoichiometrical chemical calculation, you need to do it from a balanced equation point of view. Please take note. You do it from a balanced equation point of view. This is already balanced because I have two sodium here and two sodium here on this product. I have 2 molecules of chlorine here and chlorine gas, and I have 2 at the products combining with hydrogen and sodium to give us sodium chloride. So the mole ratios are 2 to 1 to 1. But in the equation, in the question, we're told that 2.3 grams of sodium reacts. So this is the sodium part. Normally, the number of moles for each of the elements in this equation should be equal. And we're told that number of mole is equals to mass in gram over relative molar mass. Number of mole equals to mass in gram over relative molar mass. Number of mole here equals to mass in gram over relative molar mass. Now, we are given the mass in gram of sodium as 2.3, and the molar mass of sodium is 23. So what is the actual number of moles in this reaction? It is 23, which is the 2.3, which is the mass in gram, over molar mass, which is 23. When I get number of moles on this reaction, is 0.1 mole. Now, this 0.1 mole is to be used for this product. You understand? I'm going to equate it with this product. All right? And we are told that it is in excess. It is in excess. It is from here you will see. Now, because these mole ratios are the same, I don't need to tamper with it. So I just say this one is equals to, I can come to this side. Number of moles is 0.1, but we're told to look for the what? The mass. So mass in gram over molar mass. I can get molar mass, right, from sodium chloride. So how do I get it? I'll put 2 outside. Okay, I'll put 2 outside to get the molar mass of sodium chloride. It is actually sodium is what? 23 plus 35.5. So the molar mass will give me 58.5. That is, if I do this, 58.5. So I'm going to put it under there. This is 0.1 is equals to mass in gram over this 58.5. 58.5 actually the molar mass of sodium chloride. So when I multiply this by this, mass in gram I'm looking for is equals to 0.1 times 58.5. Final answer will be giving us 5.85 gram of sodium chloride. So this is it. This is it. Well, we're not taking cognizance of these 2 here because they say it's excess. Okay. Sorry. Okay. We have actually gotten the final answer. 5.85 gram of sodium chloride. Okay, so we have another question on the board. It says a compound contains 40% of carbon, 6.7% of hydrogen, and 53% of oxygen. Determine its empirical formula. So empirical formula is actually the simplest formula, representation of the constituent element in the compound. It's not the actual composition, but the simplest. Okay, so how do we get it? First of all, let us spread out the elements involved in this compound. In this compound, I have carbon, I have hydrogen, and I have oxygen. And for carbon, we're told that the percentage representation is 40%. For hydrogen, we're told that it is 6.7%. And for oxygen, we're told that it is 53.3%. Now, we're going to look for the mole ratios of these individual elements. What we do, we will divide this by the relative molecular mass or molar mass. So molar mass of carbon is 12, molar mass of hydrogen is 1, and molar mass of oxygen is 16. Okay, so here, by the time we divide 40 by 12, I'll be getting 3.33 moles. This is in mole now, because we're assuming that this percentage is mass, and that we're dividing this mass by molar mass. That's mass in gram of molar mass to give us the mole representation here for carbon. For hydrogen, it is 6.7 divided by 1, which is 6.7 moles. And for oxygen, it is 53.3 divided by 16, which will give us, again, 3.33 moles. Okay, so from here, we'll inspect each of these moles here, and which of them is the least. We'll divide each of them by the least. So we'll divide each by least. Divide each by least value. Least value. So what's the least here? The least is 3.3. So I'll divide every of the 10 by 3.33 by 3.33 by 3.33. This one will give me 1, 2. This one will give me 2, 2. This one will give me 1. So this is the empirical formula. That is the simplest. It's like LCM, So in this compound, I have the simplest representation, carbon as 1. So I write C, that's 1. Then hydrogen is 2, so I have H2, and oxygen is 1, I have O. That is CHO. That's the empirical formula. Okay. Okay, so we have another question on the board. It says, calculate the volume occupied by 2 moles of an ideal gas at 300 Kelvin and 101.3 kilopascal. So we are given the constant R is equals to 8.314 joule per mole Kelvin, and 1 kilopascal is actually 1000 pascal. Okay, so this is ideal gas law, or gas law. Using this formula, PV is equals to nRT, where P is equals to pressure, V is equals to volume, T is equals to temperature, then R and N and R are constants. They're actually constants. It's a constant. Okay, so this is ideal gas law. So we're given these parameters. We're given pressure. We're trying to find the volume. So this volume we're looking for. We can make it such a formula. So at this formula, I say V is equals to nRT over P. So every other thing here I have, the N here is 2 moles, because N is in moles. Okay, this is constant, and N is number of moles. Okay, very good. Okay, so we're given N as 2 moles. So I will say V is equals to N is 2 moles. R is given as 8.314 times temperature. Temperature is given as 300 Kelvin. Then the pressure, we have to convert that pressure. The pressure is given in kilopascals. So we'll convert that pressure to pascals. So I just multiply this by this. Okay, because it said 1 kilopascal makes 1000 pascal. So it is actually 1013 then 000. If I'm correct, 1013300. This is where the point is. 1, 2, 3. Okay, sorry, this is how it is. Okay, so from here we'll do our calculation. By the time we do calculation, the volume, by the time you press the calculator, the volume will give us 49.2 dm cube. For example, so this is simple enough. All you have to do is to know the formula. This is the ideal gas law. Ideal gas, just know the formula. PV is equals to nRT, where P is pressure, V is volume, N is number of moles, R is the gas constant, and T is the temperature. All right, so go to the next question. Okay, so we have this question on the board. It says calculate the volume occupied by 5.6 gram of oxygen gas, O2, at STP. STP stands for standard temperature and pressure. So they say it's universal constant. And we are given that oxygen is molar mass is 16, or atomic mass is 16, and molar volume at STP is 22.4 dm cube. Okay, so now this particular question has to do with Avogadro's law, volume of gas. So what we'll do is to, we know that number of moles, this concept, you understand this concept, number of moles number of moles in solid state is equals to number of moles in gaseous states. So remember, number of moles is given as mass in gram, ImG, over RMM, relative molar mass. The same thing here for gas. It's not going to be mass, it's going to be volume of that gas, and this RMM here is standard for that particular element or gas. Oxygen is 16 anyway, but for this volume, under volume, the relative molar mass under volume is this 22.4. It's the same thing as STP, volume of gas at STP, or I would say molar volume at STP. So this one is always the same thing, always constant. It does not change. So it's the same thing. You are comparing the number of moles as solid form, which is mass in gram or molar mass. For this particular situation, molar mass or that compound could be different. If I come here and put chlorine, for instance, let me remove this and put chlorine. Chlorine is 35.5, right? You understand? So this 35.5 will come here, but when it comes to this side, in the volume, it now becomes 22.4 dm cube. So this value for molar volume at STP is the same thing for all gases, no matter the element or the gas. So let me go back to the oxygen that was there before. So this is 16, right? Okay, so for here, I would say mass in gram, I have 5.6 gram of oxygen over molar mass. I will not put 16 here because oxygen is O2. So it is 16 times 2. 16 times 2 will give me 32, right? 32, correct. So the volume is what I'm looking for. And I have molar volume at STP as 22.4. So I'll make volume a formula. So I will put volume is equals to 5.6 times 22.4 all over 32. Okay, we'll do the maths. Excuse me. Final answer is equals to 3.92 dm cube. That's the volume at STP. Okay, so we have another question on the board. It says 25.0 cm cube of sodium chloride, sodium hydroxide solution neutralized 20.0 cm cube of 0.1 mole dm cube. Sodium chloride, sorry, hydrogen chloride. What is the concentration of sodium hydroxide? Okay, so this is actually under acid-base reaction, titration question. The formula for it is, okay, first of all, write out the reaction. Acid, this is the acid, plus base, sodium hydroxide, will give us salt. Okay, let me do it. Salt. Salt is sodium chloride, and water. This is a very simple acid-base reaction. Okay, and their mole ratio is 1, 1, 1, 1, 1. 1 here, 1 here, 1 here, 1 here. Okay, so but the formula is CAVA, that is C subscript A and V subscript A over C subscript B times V subscript B is equals to N subscript A over N subscript B. What are all these things I'm writing here? Let me define them. Let me define them like this. Ca is concentration of the acid. It's in the question of acid. C or Va is volume of acid. Then Cb is concentration of base. We have to look for this one. Concentration of base. And Vb is volume of base. Volume of base. Na is the ratio, mole ratio, or the coefficient of coefficients of acids. What's the coefficient? The number, the number before the acid, and NB is coefficient of base. So having defined all these terms, we can just plug in all the things that we need here. We are given Ca in the question. Ca is what? 0.1 mole, that's of acid per dm cube. Per dm cube. Okay, so I will have 0.1 mole here. Volume of acid is given as 20 cm cube. Okay. Base is not given. We're looking for that of base. Cb is not given. Volume of base is 25. The mole ratio, acid is 1 and base is 1. So everything I have here except for Cb, from here on is mathematics. We have finished with chemistry. It's maths we want to do now. Okay, so we'll make Cb subject to the formula. We'll multiply this, this, and this, then this, and this. Right? You understand the concept? This one, and this one. That is 0.1 times 20 times 1 is equals to Cb times 25 times 1. So Cb will stand on its own, while 2 will come under here. So I have 0.1 times 20 times 1 all over 25 times 1 equals to Cb. So when I do everything here, what I'll be having is 0.08 moles. 0.08 mole per dm cube. So that is the concentration of the base. Okay, so we have this question on the board. It says, given hydrogen gas reacts with oxygen gas to give us water in liquid, and the enthalpy change is minus 286 kilojoule per mole. Mind you, this minus is telling you the nature of the enthalpy. It's exothermic. We discussed, there's a video on enthalpy changes. Exothermic reactions. Yes, it's the minus. If it's exothermic, it means that heat is given out. The exo is out. So heat is given out. So the surrounding the temperature of the surrounding or where the reaction is occurring is higher than inside where it's happening. So that's just, I'm just giving you all the natures. But this is a calculation aspect. So we should calculate the heat released when 4 grams of hydrogen reacts. Actually, heat released is equals to number of moles times the heat energy change. So this is it. So number of moles times this one. This minus here I told us is for knowing the kind of reaction is exothermic. So it doesn't play in the calculation. No, so we have heat energy change. That's this one. We have it, 286. But we don't have number of moles readily. So how do we do that? How do we get number of moles? We're told that 4 grams of hydrogen reacts. So number of moles is mass in gram over relative molar mass. Okay, so what's the mass in gram? 4. Molar mass is 2. It's 2 is 2 because hydrogen is 1, then times this 2 here. So times 286. So by the time you do the maths, I'll be getting, that is 2. Sorry. 2 times 286. Your calculator, you can do that with calculator, or you can just do the maths by saying 2 times 6 is 12, 2 times 8 is 16, plus 1, 17, then 2 times 4 is, 2 times 2 is 4, plus 1, 5. So 572 kilojoule is the answer, is the number of, is the heat released when 4 grams of hydrogen reacts. Okay, so I have this question on the board. It says if 12 grams of carbon reacts with 32 grams of oxygen, what is the limiting reagent and how many grams of CO2 is produced? Okay, limiting reagent and how many grams of CO2 is produced. So this is mole ratio, limiting reactant. Oh, what is the limiting reactant? Okay, so first of all, we can write the equation. C plus O will give us CO2 Okay, so C plus O2 will give us CO2. So the number of moles of carbon, number of moles is equals to mass in gram over relative molar mass. For carbon, I have 32, and molar mass is 12. Sorry, this is 12. 12 gram. So 12 gram of carbon, about 12. 12 gram of carbon is the mass in gram, and molar mass of carbon is what? Is 12. Okay, so for oxygen, I have 32 gram of oxygen reacting, but the molar mass is 16 times 2, which is also 32. You understand? So for these two, I can quickly get the number of moles, or the moles. This is 1, and this is also 1. So 1 mole, and how many gram is produced here? You see, the theory is that the number of moles are the same for each. This is equal to this is equal to this. So if this is 1 mole, that means 1 mole will react here. So 1 mole is equal to mass in gram, which we are looking for, over the molar mass of carbon dioxide. And carbon dioxide is given as 12 times 1 plus 16 times 2. 16 times 2 is 32, right? Let's do it. 32 plus 12 over MIG is equals to 1. So 1 is equals to MIG over 12 plus 32 will give us 44. So MIG is actually 44. So mass in gram of what? Of carbon dioxide is 44 grams. So 44 grams is what is required. What is produced? What is produced? There's no excess. There's no excess. Everything is in order. 44 grams is produced. If 12 grams of carbon reacts with 32 grams of oxygen, given the mole ratio of 1 to 1 to 1. Okay? Okay, so this question on the board says, calculate the concentration of hydrogen ions in 0.01 mole dm cube of sulfuric acid. So calculate the concentration of hydrogen ions. So it means that this one has to dissociate first, so hydrogen ions can come out. So by dissociation, H2SO4 dissociates to have this, right? And this. Okay, so this is dissociation. Let me put it here. Dissociation or dissociates. Okay, so now the concentration of H2SO4 is 0.01 mole per dm cube. So I have 0.01 mole per dm cube here. You understand? Per dm cube here. So, and there's 1 mole here. So 1 mole of this gives concentration. How many moles we give to? You understand? So this one is going to be times 2 of this to give me the concentration of the hydrogen ions. So when I do the maths, I will have 0.02 mole per dm cube of hydrogen ion. So the catch here in all of this calculation is to first of all derive a balanced chemical equation, whatever you call it. At least we're tested to know that, okay, dissociation of sulfuric acid will give us 2 hydrogen ions, and by relating it with the concentration, the moles are proportional to the concentration that we are having here. So if I have 1 mole of this, I should be having 2 mole. That's 2 times this will give me the concentration of this one. So I want us to look at all these questions. There are more questions. I'm sure I will be having more videos on calculation on chemistry. If you go to the description of this video, you'll be seeing different set of calculations, even from this one I have on the board, and their answers. Even in the comment section, you will have it. So please do like this video for others to get it. Share and subscribe if you're not yet subscribed. I hope this video has been informative for you, and I'd like to thank you for viewing.